Tonight on The Sleepy Scientist, we're drifting gently through the vast cosmic ocean to visit our nearest galactic neighbor, the magnificent Andromeda Galaxy. Like a lighthouse beacon in the cosmic night, this spiral island of stars has been quietly shining its ancient light toward Earth for over 2 billion years, carrying with it the gentle whispers of cosmic history and the peaceful promise of our shared galactic future. In the quiet space of our evening contemplation, we'll float together through the serene darkness that separates our Milky Way from this distant stellar companion. There's something profoundly calming about knowing that while we rest peacefully in our beds tonight, Andromeda continues its slow, graceful dance through space, each of its trillion stars burning with the same gentle nuclear fires that warm our own sun during the day. Gently, we discover that Andromeda, also known to astronomers as Messier 31 or M31, rests approximately 2.5 million light-years away from our own galaxy. To put this vast distance into a peaceful perspective, imagine that if our sun were the size of a grain of sand on a quiet beach, Andromeda would still be more than 40 miles away, a distance so great that it transforms our cosmic anxiety into wonder at the magnificent scale of our universe. Like whispers in the night, the photons of light we see from Andromeda tonight began their journey toward us when early human ancestors were just learning to use stone tools. These ancient light particles have traveled through the peaceful vacuum of space for over 2 million years, carrying with them the gentle glow of distant suns and the quiet stories of stellar birth and evolution. As our journey continues into this cosmic meditation, we find ourselves drawn to the remarkable fact that Andromeda is approaching our Milky Way galaxy at a speed of about 250,000 miles per hour. Yet in the context of cosmic time, this represents not a violent collision, but rather the beginning of a slow, graceful galactic ballet that will unfold over billions of years, a dance so gentle and gradual that countless generations of stars will live complete, peaceful lives before the two galaxies even begin to noticeably interact. Let's drift into the fascinating discovery story of our galactic neighbor, beginning with the ancient observers who first noticed this fuzzy patch of light in their night skies, long before telescopes revealed Andromeda's true nature. Persian astronomer Abd al-Rahman al-Sufi described it in 964 CE as a nebulous smudge in the constellation Andromeda. His gentle observations were preserved in the Book of Fixed Stars, creating the first known written record of our galactic neighbor. In the quiet space of medieval observatories, other astronomers occasionally noted this mysterious celestial object. The gentle astronomer Charles Messier included it as the 31st entry in his catalogue of celestial objects in 1764, not knowing he was documenting an entire galaxy containing hundreds of billions of stars. To Messier and his contemporaries, Andromeda appeared simply as a peaceful, glowing cloud among the stars, a cosmic mystery that would take centuries more to fully understand. The true nature of Andromeda remained hidden until the early 20th century, when astronomer Edwin Hubble used the powerful 100-inch Hooker telescope at Mount Wilson Observatory to peer deeper into this celestial wonder. In 1925, Hubble made the groundbreaking discovery that would forever change our understanding of the universe's scale and structure. Through careful, patient observations that embodied the gentle spirit of scientific inquiry, he identified individual Cepheid variable stars within Andromeda's spiral arms. Gently, we discover how these special pulsating stars served as cosmic lighthouses, their regular brightening and dimming cycles allowing Hubble to calculate their distances with unprecedented accuracy. Like a cosmic ruler stretching across the vast darkness, these Cepheid variables revealed that Andromeda lay far beyond the boundaries of our own Milky Way galaxy. This peaceful revelation expanded the known universe by millions of light years. In a single moment of scientific understanding, Hubble's gentle methodology involved photographing the same regions of Andromeda night after night, watching patiently as certain stars grew brighter and dimmer in regular cycles. This meditative process of observation, requiring months of careful work, embodied the peaceful persistence that characterizes the best scientific discoveries. Each photograph was like a snapshot of cosmic time, capturing the gentle pulse of distant suns across the vast ocean of space. As our journey continues through this historical revelation, we find profound peace in understanding how Hubble's discovery transformed Andromeda from a mysterious nebula into a complete galaxy-an island universe, containing its own vast collection of stars, gas clouds, and cosmic wonders. This shift in perspective was not jarring or disturbing, but rather opened up new realms of cosmic contemplation and wonder. Let's drift into the peaceful process of understanding Andromeda's true size and scale. This magnificent galaxy spans approximately 220,000 light-years in diameter, making it roughly twice the size of our own Milky Way. Yet, even this enormous measurement becomes soothing when we consider it in the context of cosmic time and gentle stellar evolution. In the quiet space of galactic measurement, astronomers have determined that Andromeda contains approximately 1 trillion stars, a number so vast it transcends ordinary comprehension and enters the realm of meditative wonder. To put this into peaceful perspective, if we could count one star every second without stopping, it would take over 31,000 years to count all of Andromeda's stellar inhabitants. Gently, we discover that Andromeda's mass is estimated at approximately 1.5 trillion times the mass of our Sun. This incredible gravitational presence creates a peaceful cosmic anchor in our local region of SPAC-E, helping to organize and guide the motions of smaller galaxies in our cosmic neighborhood. Rather than viewing this immense mass as overwhelming, we can find tranquility in understanding how it represents the gentle accumulation of cosmic matter. Over billions of years, the galaxy's spiral structure reveals itself as a masterpiece of cosmic architecture, with elegant arms that sweep outward from a bright central bulge like gentle waves. Frozen in stellar time, these spiral arms are not rigid structures but rather density waves that move through the galaxy's disk, creating regions where gas and dust collect peacefully before condensing into new generations of stars. Now we float toward Andromeda's beautiful spiral arms, where star formation occurs in a process as gentle and natural as morning dew collecting on peaceful meadow grass. These stellar nurseries contain vast molecular clouds of hydrogen and helium, cooled to just a few degrees above absolute zero, creating perfect conditions for the quiet gravitational collapse that births new stars. In the contemplative darkness of these molecular clouds, gravity works with infinite patience to gather cosmic material into increasingly dense concentrations. Over millions of years, these peaceful accumulations reach the critical point when nuclear fusion begins, creating the gentle glow of newborn stars that will shine steadily for billions of years to come. Like whispers in the night, the process of stellar formation in Andromeda mirrors the same gentle mechanisms that created our own Sun and the countless other stars we see in our Milky Way-esque night sky. This cosmic connection creates a profound sense of unity and peaceful belonging, reminding us that we are made of elements forged in the nuclear furnaces of ancient stars, both in our own galaxy and in distant Andromeda. The spiral arms of Andromeda also contain magnificent regions of star formation called H2 regions, where young, hot stars ionize the surrounding hydrogen gas, creating beautiful emission nebulae that glow with the soft colors of cosmic fire. These stellar birthplaces appear as gentle pink and red patches when viewed through powerful telescopes, like cosmic roses blooming in the galactic garden. As our journey continues deeper into Andromeda's structure, we encounter the galaxy's peaceful central bulge, a nearly spherical region containing the galaxy's oldest stars. These ancient suns, some nearly as old as the universe itself, burn with a gentle yellow and red glow, having converted most of their original hydrogen fuel into heavier elements over the course of their long, stable lives. At the very heart of Andromeda lies a supermassive black hole, containing approximately 230 million times the mass of our Sun. Rather than viewing this cosmic giant as a source of destruction, we can find peace in understanding its role as a gentle gravitational anchor that helps organize and stabilize the entire galaxy. This central black hole feeds very quietly on surrounding material, creating a peaceful accretion process that has continued for billions of years. Let's drift into the contemplation of Andromeda's stellar populations, beginning with the ancient red giant stars that populate much of the galaxy's outer regions. These elderly suns have swelled to enormous sizes as they near the end of their nuclear burning phases, creating gentle stellar atmospheres that extend millions of miles from their cores. Their peaceful red glow represents the twilight years of stellar evolution, a cosmic sunset that unfolds over hundreds of millions of years. Gently, we discover that Andromeda also contains vast numbers of white dwarf stars, the peaceful remnants of sun-like stars that have completed their life cycles. These cosmic embers, each about the size of Earth but containing the mass of our Sun, cool slowly over billions of years, gradually fading from white to yellow to red as they radiate away their stored thermal energy into the peaceful darkness of space. In the quiet space between stars, Andromeda's interstellar medium consists of incredibly thin gas and cosmic dust, with particle densities so low that the best vacuum chambers on Earth are thousands of times denser. This near-perfect vacuum creates ideal conditions for the peaceful propagation of starlight and a gentle mixing of elements created by stellar nuclear fusion over cosmic time. The galaxy's dust lanes, visible as dark ribbons threading through its spiral arms, consist of tiny solid particles no larger than smoke particles in Earth's atmosphere. Yet these microscopic grains play crucial roles in cosmic chemistry, providing surfaces where simple molecules can form and evolve in the peaceful cold of interstellar space. These dust particles also help protect developing stellar nurseries from harsh radiation, creating gentle environments where new stars can form undisturbed. Now we float toward Andromeda's magnificent globular clusters, ancient collections of stars that orbit the galaxy like cosmic pearls strung around its outer edges. Andromeda hosts several hundred of these spherical stellar cities, each containing hundreds of thousands to millions of stars bound together by their mutual gravitational attraction. These globular clusters represent some of the oldest objects in Andromeda, with ages approaching 13 billion years, nearly as old as the universe itself. The stars within these clusters formed during the galaxy's youth, when the universe was a much different and more compact place. Their peaceful survival over such vast spans of time provides gentle testimony to the stability and longevity of gravitational systems in our cosmos. In the contemplative study of these ancient star clusters, astronomers have found that Andromeda's globular cluster system contains important clues about the galaxy's formation and early evolution. The cluster's orbits, compositions, and ages tell peaceful stories about how our galactic neighbor assembled itself from smaller building blocks over billions of years of cosmic time. Like whispers in the night, each globular cluster preserves within its stellar populations a record of the chemical conditions that existed when it formed. By studying the ratios of different elements in these ancient stars, astronomers can gently trace the history of stellar nuclear synthesis in Andromeda, learning how successive generations of stars have gradually enriched the galaxy with heavier elements necessary for planet formation. As our journey continues through Andromeda's stellar neighborhoods, we encounter the galaxy's peaceful population of neutron stars, incredibly dense stellar remnants, created when massive stars complete their life cycles in spectacular but brief supernova explosions. These cosmic lighthouses, each containing more mass than our Sun compressed into a sphere just 12 miles across, spin with clockwork precision while emitting gentle beams of radiation into space. Andromeda's neutron stars represent the endpoints of stellar evolution. For stars roughly 8 to 25 times more massive than our Sun, their formation involves a momentary violent collapse, but their subsequent lives are characterized by billions of years of peaceful spinning and gradual slowing as they radiate energy into space. Some of these neutron stars appear as pulsars, cosmic metronomes that sweep their radiation beams across space with timing so precise they rival atomic clocks in their regularity. Let's drift into the peaceful gravitational relationships that bind Andromeda to its family of satellite galaxies. Like a cosmic shepherd tending its flock, Andromeda's immense gravitational influence guides the motions of more than a dozen smaller companion galaxies that orbit in its vicinity. The largest of these satellite galaxies, M32 and M110, are clearly visible in telescopic photographs of Andromeda. appearing as gentle elliptical companions that have maintained stable orbits around their massive parent for billions of years. These smaller galaxies contain their own populations of millions to billions of stars, creating peaceful stellar communities that exist in gravitational harmony with their giant neighbor. Gently, we discover that the gravitational dance between Andromeda and its satellites has created beautiful, tidal streams long, thin ribbons of stars that have been gently pulled from the smaller galaxies over millions of years. These stellar streams trace graceful arcs through space, marking the orbital paths of the satellite galaxies like cosmic contrails that persist for hundreds of millions of years. In the quiet space of galactic dynamics, computer simulations reveal how these tidal interactions have shaped both Andromeda and its companions over cosmic time. The process occurs so gradually that individual stars experience no violent disruption. They simply find their orbital paths gently altered as they respond to the changing gravitational landscape around them. The study of Andromeda's satellite system provides peaceful insights into how galaxy groups form and evolve throughout the universe. These gravitational relationships, established over billions of years, demonstrate the gentle but persistent influence of cosmic forces operating on scales far beyond human experience, yet governed by the same physical laws we observe in our everyday lives. Now we float toward one of the most remarkable aspects of Andromeda's cosmic story, its future collision and merger with our own Milky Way galaxy. In approximately 4.5 billion years, these two massive spiral galaxies will complete their slow gravitational approach and begin a cosmic dance that will transform both participants into something entirely new. Rather than viewing this future event as a catastrophic collision, we can find deep peace in understanding it as a natural and gentle process that occurs regularly throughout the universe as galaxies grow and evolve. Computer simulations of this merger reveal that it will unfold over several billion years, creating ample time for countless generations of stars to complete their peaceful life cycles before the galactic restructuring is complete. In the contemplative study of galactic mergers, astronomers have learned that these events rarely result in direct stellar collisions. The vast distances between individual stars ensure that they will pass by each other. Like ships in a cosmic night, their paths gently curved by gravitational forces, but their nuclear fires continuing to burn steadily throughout the merger process. Gently, we discover that the merger will likely result in the formation of a giant elliptical galaxy, informally nicknamed Milky Way by astronomers. This new galactic structure will contain all the stars from both parent galaxies, reorganized into a more spherical configuration that reflects the peaceful gravitational settling that occurs after major galactic interactions. The timeline of this cosmic ballet unfolds with majestic slowness that transforms anxiety into wonder. First, in about 4.5 billion years, Andromeda and the Milky Way will begin their closest approach, with their outer regions starting to feel each other's gravitational influence more strongly. This initial interaction will trigger new waves of star formation as gas clouds within both galaxies experience gentle compression from tidal forces. Like whispers in the night, the early stages of the merger will be visible as subtle changes in both galaxy structures, with spiral arms becoming slightly disturbed and new star-forming regions appearing where gas clouds collide and merge. These changes will occur gradually over hundreds of millions of years, creating a slow-motion cosmic symphony that unfolds with the patience of geological time. As our journey continues through this future scenario, we find that Earth and our solar system will likely survive the galactic merger completely intact. Our Sun, along with its family of planets, will simply find itself in a new stellar neighborhood within the merged galaxy, possibly relocated from its current position in the Milky Way's spiral arm to a different region of the new elliptical structure. The night sky of Earth will gradually transform over the course of the merger, with new constellations appearing as stars from Andromeda join our local stellar neighborhood. Eventually, the night sky will be dominated by the bright core of the new elliptical galaxy, creating a cosmic backdrop far more spectacular than anything visible in our current, relatively sparse spiral arm location. Let's drift into the peaceful process of observing Andromeda from Earth. beginning with the remarkable fact that this entire galaxy appears to the naked eye as nothing more than a faint, fuzzy star in the constellation Andromeda. On clear, dark nights away from city lights, patient observers can spot this cosmic lighthouse as a gentle smudge of light, roughly 6 times wider than the full moon. Finding Andromeda in the night sky becomes a meditative exercise in cosmic navigation. The galaxy lies within the constellation Andromeda, which is best visible in autumn evenings from northern hemisphere locations. Starting with the distinctive W shape of Cassiopeia, observers can trace gentle lines across the sky to locate the galaxy's position. Near the star Alpheratz, in the quiet space of telescopic observation, even small backyard telescopes reveal Andromeda's true nature as an extended galactic disk. Through the eyepiece, the galaxy's bright central bulge becomes clearly visible, surrounded by the fainter glow of its spiral arms. Larger telescopes and longer exposures reveal increasingly intricate details, including dust lanes, star-forming regions, and the galaxy's to prominent satellite companions. Gently, we discover that photographing Andromeda has become a peaceful pursuit for amateur astronomers around the world. Modern digital cameras, when attached to tracking telescope mounts, can capture the galaxy's structure in remarkable detail through long-exposure techniques that accumulate starlight over minutes or hours of patient observation. The process of deep sky astrophotography embodies many of the same meditative qualities that make astronomy such a peaceful pursuit. Photographers spend quiet hours under dark skies, carefully aligning their equipment and monitoring their cameras as they collect ancient photons from Andromeda's distant stars. The resulting images reveal details invisible to visual observation, including the subtle colors of different stellar populations and the intricate structure of the galaxy's spiral arms. Professional astronomers continue to study Andromeda with increasingly sophisticated instruments, from ground-based telescopes equipped with adaptive optics systems that correct for atmospheric turbulence, to space-based observatories that can observe the galaxy across the entire electromagnetic spectrum without atmospheric interference. Now we float toward the discovery of Andromeda's place within the larger cosmic web of galaxy clusters and superclusters. Our galactic neighbor belongs to the same local collection of galaxies as our own Milky Way, a gravitationally bound group known appropriately as the local group. The local group represents a peaceful cosmic family consisting of about 80 known galaxies, with Andromeda and the Milky Way serving as the two dominant members. This galactic collection spans roughly 10 million light-years in diameter, creating a relatively isolated island of matter within the larger cosmic structure. In the contemplative study of galaxy groups, astronomers have learned that the local group is itself part of an even larger structure called the Virgo supercluster, which contains thousands of galaxies organized into smaller groups and clusters across a region, spanning more than 100 million light-years. These nested hierarchical structures demonstrate how gravity works patiently over cosmic time to organize matter on the largest scales. Like whispers in the night, the motions of galaxies within the local group reveal the ongoing influence of dark matter, mysterious invisible material that outweighs ordinary matter by a factor of roughly 5 to 1. This dark matter creates the gravitational scaffolding that holds galaxy groups together and guides their long-term evolution through cosmic time. Gently, we discover that Andromeda's motion through space reflects not only its gravitational interaction with the Milky Way, but also the influence of much larger cosmic structures. The galaxy participates in the general expansion of the universe, while simultaneously falling toward the massive Virgo cluster, creating complex orbital motions that unfold over billions of years. The study of these large-scale motions provides peaceful insights into the cosmic forces that shape galaxy evolution over time, rather than existing in isolation. Galaxies like Andromeda participate in a vast cosmic ecosystem where gravitational interactions on multiple scales influence their formation, evolution, and ultimate fate. As our journey continues through Andromeda's cosmic context, we encounter the fascinating role that dark matter plays in shaping the galaxy's structure and evolution. Computer simulations suggest that Andromeda, like other large galaxies, is embedded within a massive halo of dark matter that extends far beyond the visible stellar disk. This invisible dark matter halo contains roughly 10 times more mass than all of Andromeda's stars combined, yet it interacts with ordinary matter only through gravitational forces. The dark matter creates a gentle but persistent gravitational influence that helps maintain the galaxy's structure and guides the orbits of its satellite companions. Let us drift into the peaceful exploration of what future space missions might reveal about Andromeda's detailed structure and composition. While the galaxy's distance makes direct spacecraft exploration impossible with current technology, advanced telescopes and observational techniques continue to reveal new aspects of our galactic neighbor with each passing year. The James Webb Space Telescope, with its unprecedented infrared sensitivity and resolution, has begun to resolve individual stars and star-forming regions within Andromeda's spiral arms. These observations provide gentle insights into the galaxy's stellar populations and the processes that regulate star formation across its vast disk. In the quiet space of spectroscopic analysis, astronomers can study the chemical composition of Andromeda's stars and gas clouds by carefully analyzing the colors of light they emit. This peaceful detective work reveals how the galaxy has processed cosmic material over billions of years, gradually enriching its interstellar medium with heavier elements created through stellar nucleosynthesis. Gently, we discover that radio telescopes have mapped the distribution of neutral hydrogen gas throughout Andromeda's disk, revealing the raw material from which future generations of stars will form. These observations show how gas flows within the galaxy, creating complex patterns of circulation that transport material from the outer regions toward the star-forming spiral arms. X-ray observations have revealed Andromeda's population of compact stellar remnants, including neutron stars and stellar mass black holes that emit high-energy radiation as they accrete material from nearby companion stars. These exotic objects, while energetic in their immediate vicinity, contribute to the galaxy's peaceful long-term evolution by recycling processed stellar material back into the interstellar medium. Now we float toward the remarkable discoveries that Andromeda has enabled regarding the formation and evolution of spiral galaxies throughout the universe. As the nearest large spiral galaxy to our own, Andromeda serves as a crucial laboratory for testing our understanding of galactic physics and evolution. Studies of Andromeda's stellar populations have revealed that the galaxy has experienced several periods of enhanced star formation throughout its history, likely triggered by gravitational interactions with smaller satellite galaxies. These episodes of increased stellar birth rates have left their signatures in the ages and compositions of different stellar populations across the galaxy's disk. In the contemplative analysis of galactic archaeology, astronomers use the properties of Andromeda's stars to reconstruct the galaxy's formation history. Over cosmic time, this peaceful detective work reveals that large spiral galaxies like Andromeda assemble themselves through the gradual accumulation of smaller building blocks over billions of years. The galaxy's globular cluster system provides particularly valuable insights into this assembly process. Different populations of globular clusters, distinguished by their ages, compositions, and orbital properties, trace different phases of Andromeda's formation and early evolution. Some clusters appear to have formed within Andromeda itself, while others were likely captured from smaller galaxies that merged with Andromeda in the distant past. Like whispers in the night, these ancient stellar populations preserve within their chemical compositions detailed records of the conditions that existed during different epochs of galactic evolution. By studying the abundances of various elements in Andromeda's stars, astronomers can trace how successive generations of stellar nucleosynthesis have gradually enriched the galaxy with the heavy elements necessary for planet formation. As our journey continues through Andromeda's scientific legacy, we encounter the galaxy's role in confirming our understanding of cosmic distances and the expansion of the universe. Hubble's original measurements of Cepheid variable stars in Andromeda provided crucial evidence that the universe extends far beyond our own galaxy, revolutionizing our perception of cosmic scale. Modern studies of Andromeda continue to refine our understanding of cosmic distances through improved observations of various stellar distance indicators, including not only Cepheid variables, but also red giant branch stars, planetary nebulae, and Type Ia supernovae. These multiple techniques provide cross-checks that enhance our confidence in galactic distance measurements. Let us drift into the peaceful contemplation of how Andromeda connects us to the broader universe of galaxies that populate cosmic space. Observations of our galactic neighbor provide templates for understanding similar spiral galaxies throughout the cosmos, from nearby systems within a few tens of millions of light years to distant galaxies whose light has traveled for billions of years to reach us. The detailed studies possible with Andromeda, due to its relative proximity, allow astronomers to calibrate their understanding of galactic physics and apply this knowledge to much more distant systems. In this way, our galactic neighbor serves as a cosmic Rosetta Stone, helping to decode the properties and behaviors of galaxies across the observable universe. Gently, we discover that Andromeda's influence extends beyond pure astronomy into the realms of astrobiology and the search for life in the universe. The galaxy's trillion stars represent a vast number of potential solar systems, each possibly hosting planets where the complex chemistry of life might unfold over billions of years of stable stellar evolution. While the vast distance to Andromeda makes direct searches for exoplanets impossible with current technology, the galaxy's structure and stellar populations provide insights into the likelihood of planet formation around different types of stars. The abundance of heavy elements in Andromeda's interstellar medium suggests that planet-forming materials have been available for billions of years, potentially creating countless worlds where life might have emerged and evolved. In the quiet space of astrobiological speculation, we can imagine that if life has indeed arisen within Andromeda's vast stellar population, it has had billions of years to develop and spread throughout the galaxy. Any advanced civilizations that might exist within Andromeda would have access to the resources of an entire galaxy, with the potential for technological development on scales that dwarf human imagination. Now we float toward the philosophical implications of Andromeda's existence and our growing understanding of its properties. The galaxy serves as a powerful reminder of our place within a universe of almost incomprehensible size and age, where structures like galaxies persist for billions of years while containing the nuclear furnaces that forge the elements of life itself. The peaceful contemplation of Andromeda's vast stellar populations and long evolutionary history can provide profound perspective on human concerns and anxieties. The galaxy has existed for over 10 billion years, during which countless generations of stars have lived complete lives, recycling their nuclear products into the cosmic medium that enriches subsequent stellar generations with increasingly complex chemistry. Like whispers in the night, Andromeda's ancient light carries with it messages about the fundamental processes that govern cosmic evolution. The galaxy demonstrates that the universe operates according to consistent physical laws that produce structures of extraordinary beauty and complexity. Through the patient action of natural forces over cosmic time, the knowledge that Andromeda and the Milky Way will eventually merge into a single larger galaxy provides a gentle reminder of the dynamic nature of cosmic evolution. Rather than viewing this future event as an ending, we can understand it as part of an ongoing process of galactic growth and development that has been occurring throughout the universe for billions of years. As our journey continues through the peaceful implications of Andromeda's story, we find connections between galactic evolution and the conditions necessary for the emergence of complexity, including the possibility of life itself. The galaxy's long history of stellar nuclear synthesis has created an interstellar medium enriched with carbon, oxygen, nitrogen, and other elements essential for biological chemistry. The stable gravitational environment provided by Andromeda's dark matter halo creates conditions where planetary systems can form and evolve undisturbed for billions of years, the time scales necessary for the emergence and evolution of complex life forms. In this cosmic context, galaxies like Andromeda serve as vast laboratories where the universe experiments with different combinations of matter and energy in its ongoing exploration of possible forms of organization and complexity. Let's drift into the contemplation of how observing Andromeda can serve as a form of cosmic meditation, connecting us directly to the deep structures and processes that govern our universe. When we look at this distant galaxy through telescopes or even with the naked eye, we participate in a direct physical connection that spans to 0.5 million light-years of space and over 2 million years of time. The photons of light that enter our eyes or telescope cameras tonight began their journey from Andromeda's stars during the Pleistocene epoch on Earth, when early human ancestors were developing the cognitive abilities that would eventually lead to our current understanding of cosmic structure and evolution. This temporal connection creates a profound link between human consciousness and cosmic history. In the quiet space of astronomical observation, the act of studying Andromeda becomes a form of participation in the universe's ongoing process of self-discovery. Through human consciousness and scientific inquiry, the cosmos develops the ability to observe and understand its own structure and evolution over time. Gently, we discover that this cosmic self-awareness represents one of the most remarkable emergent properties of universal evolution, the development of local concentrations of matter and energy, such as living beings that can perceive, analyze, and comprehend the larger systems of which they are part. The peaceful practice of observing Andromeda can therefore serve as a reminder of our deep connection to cosmic processes and our participation in the universe's journey toward increasing complexity and understanding. Each observation adds to the cumulative human knowledge about galactic structure and evolution, contributing to our species' role as agents of cosmic consciousness. Now we float toward the recognition that Andromeda's study exemplifies the collaborative nature of modern astronomical research. The galaxy has been observed and analyzed by thousands of astronomers over many decades, each contributing pieces to an ever-growing puzzle that reveals the nature and history of our galactic neighbor. This collaborative approach reflects one of science's most beautiful qualities: its ability to transcend individual limitations through the peaceful cooperation of many minds, working toward common goals of understanding. No single person could hope to comprehend all aspects of a system as complex as Andromeda, but through shared research and open communication, the global astronomical community gradually builds comprehensive models of galactic structure and evolution. The international cooperation required for major astronomical projects, including space telescopes and ground-based observatories, demonstrates humanity's capacity for peaceful collaboration on projects that benefit all members of our species. The knowledge gained about Andromeda and other galaxies belongs to all humanity and contributes to our collective understanding of our cosmic environment. Like whispers in the night, the scientific study of Andromeda embodies values of patience, persistence, and careful observation that can serve as models for approaching other challenges and questions in human life. The methodical, long-term approach required for astronomical research teaches us about the value of sustained effort and the gradual accumulation of understanding over time. As our journey continues through the peaceful lessons of Andromeda's study, we encounter the galaxy's role in inspiring wonder and curiosity about the natural world. For many people, learning about Andromeda provides their first concrete introduction to the true scale and age of the universe, transforming abstract concepts about cosmic space and time into tangible realities. The visual beauty of Andromeda, revealed through telescope observations and long-exposure photography, demonstrates that scientific understanding enhances, rather than diminishes, our aesthetic appreciation of natural phenomena. The more we learn about the galaxy's structure, stellar populations, and evolutionary history, the more remarkable and beautiful it becomes. Let us drift into the contemplation of how Andromeda's future collision with the Milky Way provides a powerful metaphor for transformation and renewal in natural systems, rather than representing destruction. This galactic merger exemplifies how cosmic evolution proceeds through cycles of assembly, interaction, and reorganization that create new forms of structure and complexity. The billions of years over which this merger will unfold demonstrate the vast patience with which natural processes operate on cosmic scales. This temporal perspective can provide comfort and context for understanding change and uncertainty in human life, reminding us that transformation often occurs gradually and naturally rather than suddenly and catastrophically. In the peaceful contemplation of galactic merger dynamics, we find that the process preserves and reorganizes existing structures rather than destroying them. The stars of both galaxies will continue to shine throughout the merger, finding new orbital configurations within the merged system, while maintaining their essential nature as nuclear furnaces that convert hydrogen into heavier elements. Gently, we discover that the merger will likely trigger new episodes of star formation as gas clouds from both galaxies collide and compress, creating nurseries where fresh generations of stars will begin their long, stable lives. In this way, galactic interactions serve as catalysts for cosmic creativity, fostering new phases of stellar birth and planetary system formation. The resulting merged galaxy will represent a synthesis of both parent systems, containing the stellar populations, globular clusters, and accumulated heavy elements from billions of years of evolution in both the Milky Way and Andromeda. This cosmic integration preserves the heritage of both galaxies, while creating something entirely new. Now we float toward the recognition that studying Andromeda provides valuable perspective on the rarity and preciousness of conditions suitable for complexity and life in the universe. While the galaxy contains 1 trillion stars and likely countless planets, the specific combination of factors that have led to life on Earth may be relatively uncommon. Even within such a vast stellar population, the peaceful appreciation of this potential rarity enhances, rather than diminishes, the value of consciousness and life wherever they might occur. If life and intelligence represent relatively rare emergent properties of cosmic evolution, then their existence becomes even more remarkable and worthy of careful preservation and nurturing. The vast scales of space and time revealed through Andromeda's study can help put human concerns and conflicts into cosmic perspective, suggesting that cooperation and mutual support represent more sustainable approaches to challenges than competition and conflict. The universe provides abundant resources and opportunities for growth and development, without requiring zero-sum competition between different groups or species. Like whispers in the night, Andromeda's ancient light carries with it suggestions about the deep patience and persistence required for the development of complexity and understanding. The galaxy's 10 billion year history demonstrates that remarkable structures and phenomena can emerge through the steady operation of natural processes over vast spans of time. As our journey continues through the philosophical implications of Andromeda's existence, we encounter questions about the ultimate purpose and direction of cosmic evolution. Does the universe have inherent tendencies toward increasing complexity, consciousness, and understanding? Or do these phenomena represent random accidents in an otherwise purposeless cosmos? While science cannot definitively answer such fundamental questions, the existence of galaxies like Andromeda, with their complex structures and long evolutionary histories, suggests that the universe possesses remarkable creative potential. The emergence of stars, planets, and potentially life within galactic systems demonstrates that matter and energy can organize themselves into increasingly sophisticated patterns and relationships. Let's drift into the peaceful appreciation of how Andromeda connects us to the deep mathematical and physical principles that govern cosmic behavior. The galaxy's spiral structure reflects the operation of density waves and gravitational dynamics that can be described precisely using the language of mathematics and physics. This mathematical description of galactic structure reveals the profound underlying order that characterizes natural systems across all scales, from subatomic particles to galaxy clusters. The same fundamental forces and principles that govern Andromeda's evolution also operate within our own solar system and even within the atoms that make up our bodies. In the contemplative study of these connections, we find that human consciousness represents a local manifestation of the universe's capacity for pattern recognition, mathematical analysis, and comprehensive understanding. Through our study of Andromeda, we participate directly in the cosmos's ongoing process of self-discovery and self-organization. Gently, we discover that this participation in cosmic evolution through consciousness and understanding may represent one of the most significant developments in the universe's 13.8 billion year history. the emergence of beings capable of comprehending galactic structure and evolution represents a qualitative shift in the cosmos's complexity and self-awareness. The peaceful recognition of our role as agents of cosmic consciousness can provide profound meaning and purpose for human existence, suggesting that our curiosity about systems like Andromeda reflects the universe's inherent drive toward greater understanding and self-awareness. Now we float toward the appreciation of how Andromeda's study exemplifies the power of human imagination and technological creativity in extending our sensory capabilities across vast distances and scales. Through telescopes, spacecraft, and sophisticated analysis techniques, we have learned to see far beyond the limitations of our biological senses. This technological extension of human perception allows us to participate directly in cosmic processes and relationships that would otherwise remain completely beyond our awareness. The ability to observe and study Andromeda represents a remarkable achievement in the development of tools and techniques for exploring natural phenomena. The collaborative development of increasingly powerful astronomical instruments demonstrates humanity's capacity for sustained technological progress in service of pure knowledge and understanding. The motivation to build better telescopes and develop more sensitive detectors reflects our species' deep curiosity about cosmic phenomena and our commitment to expanding the boundaries of human knowledge. Like whispers in the night, each new technological advance in astronomy reveals previously hidden aspects of galaxies like Andromeda, suggesting that our current understanding represents only the beginning of what we might eventually learn about cosmic structure and evolution. As our journey continues through the technological aspects of Andromeda's study, we encounter the remarkable fact that modern digital cameras and computer processing techniques have democratized access to detailed observations of our galactic neighbor. Amateur astronomers around the world now routinely capture images of Andromeda that exceed the quality of professional photographs from just a few decades ago. This democratization of astronomical observation creates opportunities for widespread participation in the peaceful pursuit of cosmic knowledge. The study of Andromeda has become accessible to anyone with modest equipment and the patience to learn basic techniques of telescope operation and digital image processing. Let us drift into the recognition that this accessibility of astronomical observation provides valuable educational opportunities for developing scientific literacy and appreciation for natural phenomena. Students and amateur astronomers who observe Andromeda firsthand gain direct experience with the methods and principles of scientific investigation. The process of planning observations, collecting data, and analyzing results to learn about Andromeda's structure provides excellent training in the methodical, evidence-based approach that characterizes effective scientific inquiry. These skills transfer readily to other areas of study and problem-solving in human life. In the quiet space of educational astronomy, observing Andromeda can serve as a gateway to broader interests in science, mathematics, and technology. The visual beauty and conceptual richness of our galactic neighbor provide natural motivation for learning about physics, chemistry, and other scientific disciplines. Gently, we discover that the study of Andromeda also provides excellent opportunities for developing mathematical skills through calculations involving distance, scale, and time that help put the galaxy's properties into meaningful perspective. These mathematical exercises connect abstract numerical concepts to concrete physical phenomena. The interdisciplinary nature of galactic astronomy, involving physics, chemistry, mathematics, and computer science, demonstrates how different areas of knowledge complement and reinforce each other in the peaceful pursuit of understanding complex natural systems. Now we float toward the contemplation of how Andromeda's existence and properties might influence the development of human civilization over very long time scales. The galaxy's approach toward eventual merger with the Milky Way provides a natural timeline for thinking about humanity's very long-term future and development. The 4.5 billion year time frame until galactic merger vastly exceeds the entire history of life on Earth, suggesting that any human descendants present during the merger will likely have developed capabilities and perspectives that transcend our current imagination. The merger will unfold during an era when human civilization, if it survives and thrives, will have had ample time to develop sustainable technologies and social systems. In the peaceful contemplation of such vast temporal scales, current human concerns and conflicts appear as brief episodes in a much larger story of development and growth. The cosmic perspective provided by Andromeda's timeline suggests the value of making decisions based on very long-term thinking rather than short-term immediate interests. The galaxy's example of patient, gradual change over billions of years provides a model for sustainable development that works with natural processes rather than against them. Andromeda's stellar populations have evolved through gentle processes of nuclear fusion and gravitational dynamics that operate within the constraints imposed by physical laws. Like whispers in the night, the galaxy's long-term stability suggests that sustainable systems must operate in harmony with their environmental constraints, rather than consuming resources faster than they can be replenished. This cosmic lesson applies directly to human civilization's relationship with Earth's resources and ecosystems, as our journey continues through the long-term implications of Andromeda's study. We encounter questions about humanity's potential role in cosmic evolution over very extended timescales. If human civilization develops the capability for interstellar travel, Andromeda represents an ultimate destination that could provide resources and opportunities for continued growth and development. The galaxy's trillion stars and countless potential planetary systems offer vast frontiers for exploration and settlement that could support human civilization for billions of years into the future. This cosmic perspective suggests that current limitations in space travel technology represent temporary constraints that future technological development might eventually overcome. Let us drift into the peaceful speculation about what forms human civilization might take if it eventually spreads beyond our own galaxy to systems within Andromeda. However, the vast timescales involved in cosmic evolution suggest that even seemingly impossible technologic, our challenges might eventually yield to sustained research and development efforts. The history of human technological progress demonstrates our species' remarkable capacity for solving complex problems and transcending apparent limitations. In the contemplative consideration of such possibilities, we find that Andromeda serves as a symbol of the vast potential for continued growth and exploration that exists within our cosmic environment. The galaxy represents opportunities and resources that could support the expansion of consciousness and intelligence far beyond their current terrestrial limitations. Gently, we discover that even if interstellar travel to Andromeda never becomes feasible, the galaxy will continue to serve as a source of scientific knowledge and philosophical inspiration for as long as human civilization persists. The ongoing study of our galactic neighbor will likely reveal new phenomena and relationships that enhance our understanding of cosmic evolution and our place within it. The peaceful pursuit of knowledge about Andromeda represents a form of cosmic exploration that requires no advanced propulsion technology, only the patient development of increasingly sensitive instruments and sophisticated analysis techniques. This intellectual exploration provides immediate rewards in the form of enhanced understanding and aesthetic appreciation. Now we float toward the recognition that Andromeda's study contributes to humanity's growing sense of cosmic citizenship and responsibility. As we learn more about our galactic neighbor and its place within the larger cosmic community, we develop broader perspectives on our relationships and obligations within the universe. The galaxy's example of long-term stability and gradual evolution suggests the value of sustainable approaches to development that preserve resources and opportunities for future generations over cosmic timescales. This temporal perspective extends traditional concepts of environmental stewardship to cosmic scales and timelines. The collaborative international effort required for studying Andromeda provides a model for peaceful cooperation on projects that benefit all members of human civilization regardless of national or cultural boundaries. The knowledge gained through galactic astronomy belongs to all humanity and contributes to our collective understanding of our cosmic environment. Like whispers in the night, the shared human fascination with Andromeda and other cosmic phenomena suggests the existence of common interests and values that transcend the divisions and conflicts that sometimes characterize human social relationships. The peaceful pursuit of cosmic knowledge provides neutral ground, where people from different backgrounds can collaborate productively. As our journey continues through the social implications of Andromeda's study, we encounter the galaxy's role in inspiring wonder and curiosity that can serve as antidotes to cynicism and despair about human nature and potential. The remarkable achievements represented by our growing understanding of galactic structure and evolution demonstrate humanity's capacity for sustained intellectual progress. The beauty and complexity revealed through Andromeda's study provide evidence that the universe contains phenomena worthy of our highest aspiration and most sustained efforts. The galaxy serves as a reminder that reality includes structures and processes of extraordinary elegance and sophistication that reward careful investigation and contemplation. Let us drift into the appreciation of how Andromeda connects us to the deep sources of meaning and value that emerge from our participation in cosmic evolution. The galaxy's existence and properties reflect the operation of fundamental physical principles that govern the organization of matter and energy throughout the universe. Our ability to comprehend and appreciate these principles through the study of systems like Andromeda represents a remarkable achievement in the universe's evolution toward greater complexity and self-awareness. Human consciousness provides the cosmos with a means of observing and understanding its own structure and development. In the peaceful contemplation of this cosmic role, we find that studying Andromeda contributes directly to one of the universe's most significant evolutionary developments, the emergence of self-reflective consciousness, capable of comprehending the larger systems of which it forms a part. Gently, we discover that this participation in cosmic self-awareness provides profound sources of meaning and purpose that transcend the limitations of purely individual or even species-specific concerns. Through our study of Andromeda, we contribute to the universe's ongoing journey toward greater understanding and complexity. The galaxy's patient, gradual evolution over billions of years provides a model for sustainable development that preserves and enhances rather than depletes the resources and opportunities available for continued growth and creativity. This cosmic wisdom applies directly to human civilization's approaches to long-term planning and resource management. Now we float toward the recognition that our evening's journey through Andromeda's cosmic story has taken us full circle, from initial wonder at the galaxy's distant beauty to deeper appreciation for its connections, to fundamental questions about existence, meaning, and our place within the larger universe. The peaceful contemplation of Andromeda's properties and evolution has revealed connections between galactic astronomy and philosophy, between cosmic evolution and human values, between scientific knowledge and aesthetic appreciation. These connections suggest that the study of natural phenomena can provide guidance for living thoughtfully and sustainably within our cosmic environment. The galaxy's example of patient, gradual change over vast time scales offers perspective on human concerns and challenges, suggesting that sustainable solutions often require long-term thinking and careful attention to environmental constraints rather than rapid consumption of available resources. Like whispers in the night, Andromeda's ancient light continues to carry messages about the deep processes that govern cosmic evolution, reminding us that we participate in systems and relationships that extend far beyond the boundaries of individual experience or even human civilization. As our journey continues toward its peaceful conclusion, we find that the time we have spent contemplating Andromeda has enhanced, rather than diminished, the galaxy's mystery and beauty. Each new layer of understanding reveals additional complexity and elegance that reward further investigation and reflection. The galaxy serves as a reminder that reality contains phenomena of extraordinary richness and sophistication that exceed our current understanding while remaining accessible to patient, systematic investigation. Andromeda represents both achievement and opportunity, a testament to how much we have learned, and a promise of how much more remains to be discovered. Let us drift into the final appreciation of how tonight's exploration of Andromeda exemplifies the peaceful pursuit of knowledge and understanding. That represents one of humanity's most characteristic and valuable activities. The methodical, collaborative investigation of cosmic phenomena embodies our species' commitment to expanding the boundaries of awareness and comprehension. The galaxy's study requires and rewards many of the qualities that contribute to human flourishing more generally: curiosity, persistence, cooperation, creativity, and careful attention to evidence and logical reasoning. These intellectual virtues, developed through scientific investigation, transfer readily to other areas of human activity and relationship. In the quiet space of our concluding reflections, we recognize that Andromeda has served tonight as both destination and vehicle for a journey that has taken us through scales of space and time that stretch human imagination, while remaining grounded in careful observation and analysis. The galaxy's trillion stars continue their ancient nuclear burning as we conclude our visit, each star converting hydrogen into heavier elements through fusion processes that will continue for billions of years into the future. This ongoing cosmic creativity provides the material foundation for whatever complexity and consciousness might emerge within Andromeda's vast stellar population. Gently, we discover that our evening's contemplation has created its own form of connection between human consciousness and galactic evolution, demonstrating how awareness and understanding can bridge vast distances and time scales through the peaceful application of imagination informed by scientific knowledge. The photons of Andromeda's light that entered our awareness tonight will continue their journey past Earth into the deeper cosmos, carrying with them the gentle glow of distant stars that burn with the same nuclear fires that power our own sun. This ongoing cosmic circulation of matter and energy connects all systems within the universe through relationships of profound interdependence. Now we float toward the recognition that while our formal exploration of Andromeda concludes with tonight's journey, the galaxy itself will continue to serve as a source of wonder, knowledge, and inspiration. For as long as human civilization persists in its peaceful pursuit of cosmic understanding, the patient practice of observing and contemplating systems like Andromeda provides ongoing opportunities for developing the intellectual and aesthetic sensibilities that contribute to human flourishing and sustainable relationship with our cosmic environment. Each observation adds to the cumulative human understanding, while providing immediate rewards in the form of beauty, wonder, and enhanced perspective. The galaxy's example of long-term stability achieved through the harmonious operation of gravitational, nuclear, and electromagnetic forces provides a model for sustainable development that preserves resources and opportunities for continued evolution over cosmic timescales. Like whispers in the night, Andromeda's gentle presence in our night sky serves as a permanent reminder of the vast cosmic community of which Earth and human civilization form a small, but potentially significant part. The galaxy's patient approach toward eventual merger with our own Milky Way provides a timeline for thinking about humanity's very long-term future and development within cosmic contexts. As our peaceful journey through Andromeda's cosmic story draws to its natural conclusion, we carry with us enhanced appreciation for the remarkable universe that has given rise to galaxies, stars, planets, and consciousness itself through billions of years of patient evolution guided by the gentle but persistent operation of natural laws. The galaxy's beauty and complexity serve as reminders that reality includes phenomena worthy of our most sustained attention and most careful investigation. Andromeda represents both achievement and opportunity, evidence of how much we have learned about cosmic structure and evolution, and promise of how much more remains to be discovered. In the contemplative silence that follows our evening's exploration, we find ourselves connected to Andromeda through the ancient light that bridges to 0.5 million light-years of space and over 2 million years of time, carrying with it the peaceful glow of distant stars and the gentle messages of cosmic evolution that continue to unfold throughout our remarkable universe. The trillion stars of Andromeda continue their patient nuclear burning, each contributing to the galaxy's ongoing evolution, while participating in the larger cosmic processes that connect all systems within our universe through relationships of profound interdependence and shared participation in the deep creativity that characterizes cosmic evolution over the vast scales of space and time. Tonight, as we prepare for peaceful rest, we can find comfort in knowing that Andromeda continues its graceful journey through space, its ancient stars burning steadily in the cosmic darkness, its spiral arms slowly rotating with the stately patience of galactic time, and its peaceful approach toward our own Milky Way proceeding with the gentle inevitability of cosmic evolution, guided by the fundamental forces that govern all matter and energy throughout our extraordinary universe. Good night from the sleepy scientist.